Morning, everybody. Welcome to a dark, spooky morning of Chem 1105 with your host, Dr. White. Well, I just did a retake. All right, important information. Remember, labs are due on Tuesday now. If you get them in too late, you'll get 0 points. You don't want that. I don't want that. So get them in. If you need help with any of your labs, guess what? Come to my office hours, Monday and Wednesday from 5 to 6:15, or after lab tomorrow. Last week's lab, you have until Wednesday morning to get it in, or you'll get 0 points. Don't do that, please. All right, let's get back to where we were on Friday. By the way, did anybody happen to think of the fact that the air around us is a solution and that nitrogen is the solvent, the component of the solution present in the greatest amount, and oxygen is a solute? Did you have any pop? You know, my favorite Dr. Pepper or Werner's, and you think, whoa, this is a solution too. You don't have to say the whoa part. And oh, I almost forgot. Important last minute announcement. There are only 6 shopping days till Halloween. All right, on Friday, hold on, glass clean off time. That's better. I started talking about the concept like dissolves like. And this is a very important concept. And we'll come back to this later because this explains how soap gets you clean. But you didn't think the next time you wash your hands, you're doing organic chemistry. You are. And it involves like dissolves like. Now, one of the things that's important about like dissolves like, and this is one of the few things, yes, you have to memorize, are polar and nonpolar substances. The most polar thing in our world, in the universe, is water. Salts like sodium chloride are polar. Alcohols, like drinking alcohol, rubbing alcohol, both are in water, are polar. And you don't think of it, but sugar, what we call sucrose, the white stuff that you put in your coffee, tea, or if you're cooking into things to make it sweet, is really a many alcohol, and these are all polar. Now, nonpolar, gasoline is nonpolar, vegetable oil is nonpolar, Vaseline is nonpolar, baby oil is nonpolar, and later on I'll talk about, you don't think about it, but dirt and grease are nonpolar. So what is this role? What role the polar and nonpolar substances play in the concept like dissolves like? And it is like solutes are soluble in like solvents or other like compounds. And what this really means is polar solutes or polar things are soluble in polar solvents, and nonpolar solutes are soluble in nonpolar solutes. And if you mix the two together, polar and nonpolar, they're not soluble. And it's time for Dr. White to be subtle, or I already am, but let's do it officially. So what like dissolves like means is if you have something polar, it will only be soluble in other polar things. Like dissolves like, if you have something that's nonpolar, it's only soluble in nonpolar things. And here's the list again. Now, I'll teach you later on. Oops. Vinegar is water and a chemical I'll teach you about later this semester called acetic acid. That's what makes vinegar that sour taste. I don't think anybody's going to be going around doing shots of vinegar. At least I won't. But anyways, vinegar is mainly 96% water. Now, how many of you, and let me stop sharing, have ever seen oil vinaigrette dressing? You can make your own, which is always better. But my mother used to love Wishbone oil vinaigrette dressing. Ours is called Wishbone. I don't get kickbacks from the company. How many of you have ever seen in the supermarket a bottle of oil vinaigrette dressing? You'll see two layers. Why? Because one layer is mainly vegetable oil, and that's on top, or it could be, if you really got some money, olive oil, or it could be soybean oil too. And the bottom is the vinegar, which is mainly water. And if you shake it up, you put it on your salad, and then when you put the bottle down, all of a sudden, whoop, they separate. Why? Like dissolves like. Water is polar, vegetable oil is non-polar. Now, how many of you have ever gone into a gas station after it's rained and there's some puddles on the ground by the gas pumps and the sun comes out and you see that rainbow on top of the little puddles? That's because underground people are sometimes sloppy, not Dr. White, because I'm a chemist and I know better, and let some of the gasoline, either they overflow their tank, gas tank, or there's some dripping out when they put the pump nozzle back where it should go next to the pump, and that gets underground. Gasoline is non-polar. Water from the rain, how do you like that? From the rain is polar, and they don't mix. So the gasoline, which is a lower density, which you know about, is on top of the water, higher density. When the light comes through, that refracts it, separates it, just like a prism would do, into different colors. And that's why you see that. Wow, this is getting interesting. So remember, like dissolves like. Polar solutes are soluble in polar solvents. Non-polar solutes are soluble in non-polar solvents. When you mix polar and non-polar together, guess what? You don't have something that's soluble in the other thing. Now, if we look at the list, if I pull it up correctly, if you notice, vegetable oil and Vaseline are non-polar. And a number of years ago, at another school, I was teaching this kind of general chemistry. I had a really sharp student, and in a lecture, that's when we were still face-to-face, he asked me a question. You know, there's no such thing as a dumb question. This is a good question, a real good one. And he said, well, if like dissolves like is true, if I mix vegetable oil and Vaseline together, will the Vaseline be soluble in vegetable oil? I said, it should, but I don't know as a fact. In chemistry, in science, we go in the lab and prove something's true or not. Now, like dissolve like is a rule of thumb. Wait, it's on this thumb. Yep. But anyway, was that a bad joke or is that a bad joke? But I'll still use it. But anyways, it's true about 95, 97% of the time. So I told them, would you be willing next time we're in the lab, if I give you a beaker, give you some vegetable oil and Vaseline, mix it together in front of the class and see if it is soluble? He said, sure. I said, okay. So next lab, we got in the lab, gave him a beaker, small beaker, some vegetable oil, some Vaseline, or it's also known by the non-trade name petroleum jelly. And he mixed some together, stirred up with a glass rod, and lo and behold, like dissolve like worked. It was soluble. Now, why you'd want to do that, I have no idea, but it really does work. So let's have some fun with like dissolves like. Hang in there while I print. If I could write, I'd do this quicker, but most of you can't read cursive. Oh, that's sad. One of these days I'll be finished. All right, I'm gonna let you solo on this one. If count 5 points, yep, says it right on the screen. If compound Z25 is soluble in vegetable oil, but not soluble in water, and compound Q11 is soluble in, I like my new compounds I'm creating, is soluble in water, but not soluble in vegetable oil, then what are the polarities of Z5 and Q11? And the most dreaded words in a question, how do you know this? Your turn. Yeah, it's time for you to vote. Don't forget to vote. All right, looks like everybody's done, so let's get to work. What do we know? We know that water is polar and vegetable oil is nonpolar. And you know, like dissolves like. And because of that, Z5 is soluble in vegetable oil, which is nonpolar, I'm sorry, and therefore Z5 is nonpolar. Boy, I've got polar on the brain today. No, I'm not going to watch Polar Express movie. So Z5 is nonpolar. Now, Q11 is soluble in water. And water, as we set up here, is polar. And because like dissolves like, Q11 is polar. So really all you have to do is write down Z5 is polar, Q11 is, I'm doing it again. I got to move on from this stuff. I got polar on the brain. Z5 is, Dr. White, get it right, nonpolar because like dissolves like, and Q11 is polar, again, because of like dissolves like. So all you'd have to put down for the correct answer and getting 5 points is Z5 is nonpolar. Oh, I got it right this time. Q11 is polar. How do you know that? Like dissolves like. And this rule of thumb, oh, it got on this thumb, is used for many things, but the most important thing is cleaning things. How do you clean your hands, your hair, your clothes? Use soap. I'll teach you later on. Soap gets things clean because of like dissolves like. And I'll teach you that later in the semester. So you got something to look forward to. All right, any questions about like dissolves like? And next time you wash your hands, wash your dishes, or wash your clothes, or wash your car, that's on tap this weekend because I want to wax it before the winter comes. You're getting things clean because of like dissolves like. And we'll get into that when we get into the organic portion of this class. All right, let's move on. All right. Click. I'm turning the switch. Will this be on the test to the off position? I think you've all heard the term electrolytes. Electrolytes are solutes that separate into ions when dissolved in water. Salt is probably the most famous electrolyte. I don't know if fame is the right word, widely used electrolyte. And important thing, solutions of electrolytes conduct electricity. And that's pretty important, which is why when you're near water, do not have any electricity like that can drop into the water, like a hair dryer or other things, because it will conduct electricity to you and kill you. Now, interesting thing. You and I cannot get our hands on totally pure water, H2O, easily. There's a way I might be able to do it, but it's still iffy. And that's why it's dangerous to be electricity around water. Normal tap water, which in the chemical industry we call city water, has lots of ions in it. How many of you ever heard of hard water and soft water? Give me a thumbs up. I see one person. Oh, no, you don't. Well, I'm going to have to teach you something right now. And that is hard water has a lot of ions in it, generally about 150 parts per million or more. Soft water has much less ions in it, usually 50 ppm or less. And when you have a water softener, what you're doing is removing a lot of the ions. Now in Chicago, depending where you live, Chicagoland, Lake Michigan water isn't that hard, but it still has ions in it. Let's see something. Never done this before, so this is a Dr. White first. Unfortunately, here it is. Lake Michigan water is about 104 ppm. And when you go above 150, you got real hard water. And 50 is soft. Here I have soft, slightly hard, hard, very hard. So that's an important thing about electrolytes. Now, electrolytes, and here I'm getting way beyond my level of expertise, like totally, but electrolytes help your body work properly. And if you drink too much water, and one way for your body, and now I'm way beyond my level of expertise, drink too much water in a short amount of time, when you get rid of the water, urinate, that's one way of your body to get rid of ions. And what happens is you could flush all the ions out of your body, or a lot of them, and that will kill you. And unfortunately, years ago, they used to have these, how stupid can you be? Well, we learned. Certain radio shows had contests for their listeners where they bring some people together and say who could drink the most water in a certain period of time. And these people would drink tremendous amounts of water, and it happened more than once. And they finally put a stop to it, at least I hope they did. I haven't heard about it in years, where people would die because you flush all the electrolytes out of your system. Ions, salts are polar, and they're very soluble in water. So don't drink too much water, but drink enough. And if you notice, when you perspire, you also lose salt. If you've ever worn an old hat or something, a lot of times in the summer, you'll see a band is, when it dries out, a white band or white on there, and that's the salt from your body and your electrolytes. And if you've ever worked in a factory or a plant, chemical plant, you'll see they have in the break rooms for the workers salt tablets. So when it's real hot out and chemical plants outside are not, most of the time you are outside, uh, you'll sweat a lot and you lose a lot of salt. And so you don't get sick, you take salt tablets, which are electrolytes. Again, this won't be on test, but it's good knowledge for you to have. All right. Oh, one other thing. I don't get any kickback from this company, but if you've ever seen sports drinks like Gatorade, all you have to do is look at any football game or other team sports with the towels and the water bottles that say Gatorade. Gatorade are different electrolytes, salts with some sugar and flavoring to make it taste better. And that's to replenish your electrolytes. Years ago, I got real sick and I wasn't drinking enough water. And I went in and my doctor said, based on some tests for other things, said, you're really low. They did some blood tests on your electrolytes. Go out and buy some Gatorade and start drinking it. I don't like it. Says, would you rather be dead? Guess what? I've learned to like it. In case you're wondering, I survived. All right, let's move on. Switch is still off. Non-electrolytes are solutes when dissolved in water, do not separate into ions, and do not conduct electricity. Example, this would be sugar. You put sugar into your tea like I did, it's a non-electrolyte, switches off for this one slide also. All right, switches back on. When we talk about solutions, an important concept is solubility. And that describes the amount of solute. Remember, solute is the component or components of a solution that are present in less amounts than the solvent, which is present in the greatest amount. So solubility tells you the amount of solute that can dissolve in a given amount of solvent. Now, time for Dr. White to be subtle. Now, the solubility, and the next couple of slides, this hint is also going to be true. Solubility is the maximum amount of solute that will dissolve in a given amount of solvent. And what I don't have here, but under certain conditions such as temperature. And let's go out to the internet. I might have mentioned this before, but Wikipedia has been so heavily policed by chemists, including yours truly. I had the credentials that I can do that, and they do make changes when I asked in the past, that it's been years since I've seen any major mistake, anything to do with, and this only applies, chemistry. Now, this is Wikipedia. I used to say Wikipedia. My students would yell at me, it's Wikipedia. They trained me. All right, sodium chloride, table salt. If you look on the right and scroll down, you have names. IUPAC means the official chemical name. I'll talk more about that later in the semester. And you'll see if you scroll down, properties, and you'll see melting point, boiling point, and look, the solubility of water. At 25 degrees Celsius, the maximum amount of sodium chloride, table salt, you can put in 1,000 grams of pure water. I guess don't try it with impure water. But anyways, it's 360 grams. You can't put one more molecule than 360. If you do, it won't be soluble and it will sink to the ground. Switches on. So solubility teaches us or tells us what's the maximum amount of solute that will dissolve in a given amount of solvent. Now, when we talk about solutions, there are different types. First type is a saturated solution. That's the solution that contains the maximum amount of solute that can be dissolved under the conditions which the solution exists. So if you have a saturated solution, you cannot put one more molecule dissolve into that solution. If you do, it will precipitate out. Precipitate, that means a solid forming in a liquid, which I'm assuming the solution is for this case. And therefore, if I ask if you have a saturated solution of, I don't know, potassium chloride, and you put in 1 more gram of potassium chloride, will it dissolve? And the answer is no, because you've already reached the limit because you have a saturated solution. Now, a dilute solution is a solution that contains a small amount of solute relative to the amount that could dissolve. So if I could put 360 grams of sodium chloride in 1,000 grams of water, but instead of that, I only mix 5 grams of sodium chloride in 1,000 grams of water, I could say I have a dilute solution of sodium chloride. Again, it's a solution that contains a small amount of solute relative to the amount that could dissolve. Now, important life story lesson. Back in my younger days when I used to go to bars more, like a lot more. But anyways, especially in East Lansing where I went to grad school, they had 5 monster bars, not for monsters. The smallest of those 5 bars, I think the LEI right off Grand River in East Lansing, if it's still there, could hold the smallest one, 750 people. The largest one was farther east on Grand River, and I think it was in a barn, I can't remember the name, that held about 1,500 people. And the bartenders did not like being told chemistry, especially, you know the drink you just made me? That's pretty dilute, otherwise known as watering down. And they did not like being told that. But after a good tip and a good look, like, come on, it's dilute, I got better drinks. But I wouldn't advise you trying that. So remember, a dilute solution is a solution that contains a small amount of solute relative to the amount of that could dissolve. Now, the opposite of that is a concentrated solution. A concentrated solution is not saturated, but it's a solution that contains a large amount of solute relative to the amount that could dissolve. As I mentioned or showed you earlier, you could have 300 of maximum solubility of sodium chloride, table salt. Remember, please pass the NaCl. in water is 360 grams per 1,000 grams of water. And if you had 300 grams of sodium chloride or 330, less than the maximum amount, grams of sodium chloride in a 1,000 grams of solution, you could call that a concentrated solution. Now, when I was younger, when I was a kid your age or actually younger, the only thing you could find, unlike now, is concentrated orange juice. And does everybody see the Minute Maid frozen concentrated orange juice on your screen? Well, you should now. All right. Thumbs up, people. Thank you, Ruben. Thank you, Taylor. All right. And what this means is there's a large amount of concentrated orange juice, or the chemicals that make up the taste and other aspects of orange juice. Orange juice has water in it. Nowadays, I'm not a big orange juice person. You buy it regular, where it still has the water in it. Why concentrated? Well, back then it was a lot cheaper to ship it without the water. And how do you make orange juice from this? You add water. And if my memory serves me correct, you add 1 can, this whole can, then you use 3 cans of water, or 3 or 4, and that's how you do it. Let's see if they have instructions. No, I don't have it. But anyways, and time for a funny Dr. White story. Ooh, you're getting a lot of them today. When I was undergrad, I went to Illinois Institute of Technology. I was in a fraternity, Alpha Epsilon Pi, nicknamed the Apes. Yeah, we were a wild bunch. We also got the highest GPA of all the fraternities on campus, smart and wild. And we had one of my fraternity brothers, whose nickname was, I won't tell you, but anyways, he used to like to eat frozen concentrated orange juice. Ugh. You see him sitting there with a spoon and a can of, oh, it's just like ice cream. No, it's not, but he loved it. Why do I still remember that? Don't know. All right, so concentrated solution contains a large amount of solute relative to the amount that could dissolve. Now, this one right here is probably one of the most important things about solutions I'll teach you. Ooh, there was some dust on my tablet. Sorry about that. Let's try on this side. And that's an aqueous solution. Aqueous comes from the Latin word aqua, water. And an aqueous solution is a solution in which water is the solvent. This is new. So aqueous solution is a solution in which water is the solvent. And it's indicated by something I'll teach you later on, bracket, AQ, close bracket. Oops, I forgot. You people don't know cursive. and smaller case, bracket A, then a Q, then close bracket. That stands for aqueous, which means aqueous solution, and that tells you water is the solvent. Now, you can also have non-aqueous solutions, which mean water, a solution in which the substance is other, which a substance other than water is the solvent. So that's non-aqueous. And when you go into a gas station, you hope to buy non-aqueous gasoline because you don't want any water in your gasoline. And over the last couple of decades, gas companies have been pretty good in that. Why? Because come winter, if you have any water in there, it will, because it's lower density, sink and gather up and get in the bottom of your gas tank and freeze your gas line. Now, to do away with that, or to stop that from happening, there's a product called heat, and it uses the concept of like dissolves like. Ooh, do you remember that? I hope. And it helps keep the water out of your gas lines. And many years ago, I religiously, about once a month, would put a bottle of heat in my gas tank. But I don't know exactly when they switched over it, but when they started adding ethanol to your gasoline, which is soluble, it's one of those both soluble in water and gasoline, it helps keep the water out, which is what heat used to do. So I haven't bought heat in ages because you don't need it with the ethanol present. And that's non-aqueous, where anything but water is the solvent. Now, switches off, but just interesting. What affects solubility? Well, what solvent you're using, the temperature which you're trying to dissolve things. If you've ever made a sugar water solution called a syrup, to get the sugar to dissolve quicker, you heat it up. Now, what are you trying to dissolve in the solvent? That will play a role in the solubility. Are other solutes present? That will affect solubility. And even what's the pressure? But the two most important things that affect solubility and switches off for this slide are the solvent and temperature. Now, the effect of temperature on solubility, as I just mentioned, the solubility of a substance depends on the temperature. For most, not all, solubility increases as the temperature increases. So what do you do if you want to dissolve something quicker or more? You heat it up. For most, not all solvents. An exception is this is called ammonium chloride. And this is an interesting one. You cool water down to make it more soluble. It's just the opposite. It's only one of the few I can think of. But for most solids, like salt, sugar, things like that, to make it more soluble, you heat up the solution. Now, how many of you have ever seen a glass of milk? How many of you have ever seen ketchup? And you say, oh, Dr. White, milk, it's a solution. And the answer is no, it's not a solution. It's something called a colloidal dispersion. Now, what is a colloidal dispersion? And before I go any further, I'm giving you guys a lot of hints today. Now, a colloidal dispersion, unlike a solution, is a dispersion. That's the key difference of small particles of one substance in another. Mixtures in which the materials do not dissolve, but are dispersed. And this I won't ask you. Right here, you use terms like dispersed phase and dispersing media. Dispersed phase is equivalent, but not the same as solute. And dispersing media is solvent. Now, this is really important. Unlike solutions, colloidal dispersions, colloids, which is a shortened term for colloidal dispersions, disperse light that's passed through them. In other words, if you take a solution, and I see I'm almost out of time and I don't have my fancy flashlights here, but if this is a solution, let's assume there's sugar and water there. It's really water, but pretend it's sugar and water. If I took my flashlight, and tomorrow I'll bring a flashlight, and anyways, you'll see the light through here. If this were a glass of milk, and you can try this at home, take a flashlight and a glass of milk, and guess what? No light comes through. That's because the little particles that are dispersed block the light and disperse it and stops it from going through. And that's one of the main ways you can tell if something's a colloidal dispersion or not. If you want, you don't have to, but take some ketchup, put a flashlight behind it, and no light will come through. That's because ketchup is not a solution, it's a colloidal dispersion. Do the same thing with the mustard. Hopefully you have some good stuff. You know, a good coarse ground mustard is one of my favorite, and also the real hot mustard. Anyways, take a flashlight, go like this, and you won't see anything there. Oh, tomorrow I'm going to have a show, Dr. White's show and tell. I'll bring some of that. I don't have any milk in the house, but I do have ketchup and barbecue sauce and mustard, and you'll see if I'm lying to you. Oh no, we've run out of time. Time flies real fast when you're having fun with Solutions and Dr. White. And with that, I'm going to say, gang gesund, goodbye. Don't forget, hand in the lab tomorrow. You don't want to lose points. They're easy points to help you get a good grade if you turn them in. Also tonight or afternoon at 5 to 6:15, I'll have my office hour. If you have any questions, stop by. And with that, I'll see you tomorrow. We were gonna do the chapter 6 problem set tomorrow, but I'm gonna hold that off till Friday. With that, bye now. Gang gesund.